right, well, good afternoon, everyone, and thank you for joining us today. I'm Janice Kleins, Marketing Manager for the Slag Cement Association, and today's webinar is an introduction to the SCA Lifecycle Assessment Calculator. Our presenter is Shawn Kalyn. Shawn Kalyn is a Technical Service and Sustainable Engineer for St Marys Cement. As Technical Services Engineer, Shawn works with the concrete partners in promotion, customer cement, and concrete technical support, LEED, durability, quality, troubleshooting aspects with respect to Portland cement, slag cement, and concrete. As a sustainable engineer, he is involved in both cement and concrete low carbon initiatives such as industry PCRs, EPDs, and concrete sustainability groups. For today's webinar, Shawn will be giving a demonstration of the SCA Lifecycle Assessment Calculator. The demonstration will show how users can use the tool that is based off of NRMCA industry EPD and benchmark information V3. Shawn will show us where to download the tool from, the different functions to enter mix and see the environmental impacts like global warming potential and other key indicators used to support low carbon concrete and other environmental initiatives. The SCA tool can be used by multiple users from designers, contractors, and ready-mix concrete producers to communicate low carbon options like using slag cement. Please put all your questions in the chat and Shawn will answer them at the end of the presentation. And this presentation is being recorded, so if you have to pop off early, no worries, we'll email it to everyone. And with that, I'm going to turn it over to Shawn.
Thank you, Janice. I'd like to welcome everyone for being here for this demonstration. If you have any questions, if you could, please put them in the question and answer period. We're going to probably try and spend about 15 minutes on a PowerPoint presentation on how to use the tool, and then we'll actually go into the use of the tool and show you demonstrating two different options. One option as if you're looking at a specific mix and you're trying to design one and give yourself different options. And the other one would be more like if you're looking at it from a project base and looking at how do I do the numbers that I'm looking for, or be able to reduce the numbers depending on the aspects that you're looking at for. So with that, we'll get started. So kind of like what Janice was talking about before, building product disclosures, EPDs are well out there right now. And also, as you can see, there's a lot of them. But one thing that we want to make sure that if we are using EPDs, that we want to look at the whole life cycle aspect of the project. So we don't want to just look at the material ingredients and saying, okay, here's my lowest number of material ingredients. It may not make sense for the whole project. So this tool that we're going to show you right now is going to be based on the mix and the materials that would go into it. However, you can see that when we're using this, you might have a material or a mix design that may have a high amount of number, but you might be able to make that up in the other portions of the project, depending on the volumes and the applications that are going into it. So not necessarily having a lower carbon one may not be beneficial depending on the aspects. But if we look at it as a group and as a whole, then we're going to see that. And one of the things that I also like to mention too is that when we look at EPDs themselves, there are industry ones and then there are product specific ones. So one good thing to do is cement manufacturers and ready-mix producers is to be involved in the industry EPD involvement, because for two reasons. It also lets you go through the process and understand how it is and be able to lower your carbon impacts and other impacts, because now you'll understand how to do it. The other aspect about it, which is good compared to, say, a type 3 EPD, which is just product specific, is we can then get a lot more data and a lot more data sets that is going to give us more information of what's going on. And it is better to have 1,000 people moving the needle downwards than just having one item that doesn't really move that item down. Now, product specific EPDs, type 3s are good as well. And they're also good to be able to see, am I demonstrating between these industry ones? Am I coming down, or how am I impacting my stuff? So there's nothing wrong with the type 3 EPDs. However, the industry ones are a good start and a good basis point to go on to, because like I said before, statistically, I'd rather have 1,000 points of information than one single point of information. And with that, what we'll go into is how this tool was made. So when we look at EPDs from the Portland Cement Association and the Slag Cement Association, they created their industry EPDs. This is their second iteration. So they started and issued the last one for Slag was in July 30th of 2021. Then the PCA had just created and finished their Portland Cement one. And this one, because of the impact of changes now and the environmental regulations, as well as trying to lower the carbon footprint, and you'll probably see in some other items or in some other aspects, you're going to see the concrete roadmap and the cement roadmap that's global, as well as local to the United States and Canada, have all made pledges to reduce our carbon footprint by 2050 to be at zero carbon as a net in concrete. So with that, here's some of the little aspects of it. So when we use Portland limestone cement, it's a little bit more of an environmentally friendly one because it's going to have less impacts on it. So that was introduced into this one. And then the industry NRMCA industry EPD then got updated when they saw that the new Slag one was done, the Portland cement one was done, and now the new Portland limestone one was done. So now we have the EPDs in version 3 for the NRMCA. So when we look at it, this is what it would look like. You can go to the NRMCA's website, just like you can go and you can download the information on there. Also on there, the NRMCA also, because they're a program operator, have a lot of the product specific EPDs on there, as well as good links to show you to where you can get to the other EPDs, such as the Portland Cement Association ones and the Slag ones, which are housed on the program operator ASTM International right now. So when we take all of this and we combine it together, basically what this tool that we're talking about today is a life cycle calculator assessment. So it's not really an EPD, but it's looking at the industry information that was there. And instead of having to scroll it down, so if, for example, if I show you this, this is the industry EPD. And what you would do right now is if you didn't have this tool, is you would kind of go and look around. And in this case, we're going to say we're looking for a, let's go to this one right here. Yeah, let's go to the lightweights. Let's go into, see, we're scrolling around. We're trying to figure out which one would be the one to use. So if we're looking at a 6,000 PSI concrete with no slag or no fly ash, we would go here and look here. Then if we did another one and we said, well, what is it with 25? We're going to try and estimate what it would be between these two numbers. So really, when we're now using this SCA tool, we're not having to do that. And we'll go over and show you how that works. So one way we can do this, and the first way that we start, obviously, is to go to slagcement.org and we click on the sustainability aspect of it. And then from there, we can download the EPD or the EPD if we want, or we can also download this tool. And in here with this tool, there's going to be two options. There's going to be the older version that we had on the previous industry information, and now the newest one. So let's say you want to look back and say, okay, I did this mix design now. What would that mix design have looked like from in the past one? And you can see how those improved. So one of the things we want to do is when we go to download this, you're going to enter in your information and then click submit. And then after you click submit and you agree to the usement of this calculator, because one of the things is this is an informational tool purpose. So we are not looking to make mix designs. All of those should be done normally like we would do through ACI and through the proper channels. And obviously any of these mixes that you are going to look at doing in here or seeing, we also want to make sure that those are verified and tested in concrete and make sure that the contractor, the designer, and the end user are all happy with what they're looking to get. So obviously this is that information. All you have to do is hit accept if you want to accept. If not, then you don't have to download the program. Like we said before, you can click on which version it is, version 3 or the old version 1. Then once we get into the tool, we've got this downloaded. You're going to see, which most likely will end up happening, is before you can accept and decline on the bottom in your Excel, you're going to see up on the top where it says enable editing. you're going to want to enable and hit this first and accept that. Because if you don't do that first, then this portion down here won't work. So you want to enable editing, and then you can click accept and continue. And then you'll be getting into the program. On the program, you're going to see 5 tabs. There's going to be a tab called Introduction. That's going to give you an information, the background, how it was all made, kind of like what we were just talking about, and give you some directional information on that. Then you're going to get into the slag substitution tab. This is a key one that we can use to make it more local, or we can go to the whole US as an aspect and see those different impacts. Then there's another tab for custom mixes. Then there's a comparison to benchmark, and then the whole building impacts. So when we look at using the SCA calculator inputs, and we look at the slag substitution tab, like I was saying before, we're looking at a regional section. So right in this tab here where it says regional Midwest, I could select that to change it from Midwest to NRMCA, or I could change it to South Central. And you could ask, well, why would I want to know that? And why does that matter? Well, when we look at these mixes and the way that they were put in on the NRMCA, because they made their benchmark report, right, they are able to tailor it more towards the mixes. And if it's for 4,000 PSI or 3,000 PSI, what generally would be a mix that would be used in that area of the volumes of the total cementitious. So you might see in the benchmark report, we're going to see that the 3,000 PSI benchmark, it might show that you had slag in there, you had fly ash, and you had that. That is the average of what would have been in for those areas. The other aspect of it too that changes is depending on the electrical grid that's used. That is a big impact on the global warming potential. So if we're looking at the eastern section versus looking at the Rocky Mountains, we're going to see that in the eastern section that they have no coal burning power plants. So if there's no coal burning power plants and most of their power is coming from hydroelectric and nuclear, you're going to see a lot lower impacts just simply because of the power grid. Okay, so when we look at the slag calculator substitution ones, we can select the different mixes. So we can select in using this tab in this section here where it says adjust mixes, we can select the ones that are already there. Ones that are already there are ranging from 100% OPC mixes from 2,500 PSI to 8,000 PSI. Also in there is the benchmark mixes showing those same information, as well as the lightweight mixes, so a 3,000, a 4,000, or 5,000 PSI. And then when we actually get into the custom mixes, so before, if you haven't used this yet, you're going to see that you're going to have 10 options or 10 spots where you can add some more into there. So when we make a custom mix and we go to adjust this selection section, we're going to see that the mixes that we had put in have popped up there. We can now take that and look at it and compare it to, we can compare when we add in more slag or less slag to see what we need. And a lot of these cases where this can help us out is especially now, such as things like a GSA and the new BABA, laws that have come in are now requiring low carbon cement and low carbon concretes to be used. And in those cases, like the GSA has now created a sheet or a template that says, we want, if you're using a 3,000 PSI mix, that we want you to have a global warming number of this or less. So we'll be able to use this tool to see, okay, did my mixes I'm looking to use already, is it going to be higher or lower than the number I need to get at? And then if you need to, a quick way to look at it is to take this, and if you were looking to do it with slag, is you can take this slag scroller and see, okay, what percentage do I need to be able to get to that point? This right here is your custom mix tab. So when we go into the customer mix tab, we can actually go in here and type in the mixes. So we would type in the ID that we want for it. We can look at the benchmark strength category. We can look at, is there Portland cement? And like this one, which is different than the old version, is now we have the Portland limestone cement. So we can, in some cases, we could look at, hey, if I did this with ordinary Portland cement and all I do now is swap out it with PLC, what are those impacts and how did I change that? we can now start to see that in this design. And we can put in all these mixes, and like we said before, we can put up to 10 mixes in this aspect. Once we got those mixes typed in there, we can go to the comparison to benchmark tab. And when we go to the comparison to benchmark tab, those mixes that we had put in there, we can look at it on this graph to see, okay, compared to the 4,000 benchmark or the 3,000 benchmark or 5,000 PSI benchmark that we might have been doing, we can see how each one of those mixes are compared relatively to the industry benchmarks for those applications. And what we're going to see is we're going to see climate change, ozone depletion, acidification, eutrophication, smog, and depletion of non-renewable energy resource or energy resources. So we can use all of those impacts, because in some cases they may have it be more worried about the lowering the carbon or climate change aspects, or in some cases they might be looking at acidification and seeing how does that impact it. And you'll see that in some cases you may have some materials and some use, they may help you on the global warming aspect, but some of the other indicators may go up. The other aspect that's also in here is after we're looking at it. So if we're looking at it as a designer or a contractor who has built this job and is already building it, and let's say that during the phases of a job, and as we know, depending on whether you're in the southern climate or northern climate, you may have the ability to change your mixes depending on the ambient temperatures that are out there and the time of year. So in some cases, if we're using slag, we know that slag likes heat. So we know that we'd be able to use more slag during the summertime. But when we're getting into the colder months, that we're going to want to be using less, simply for the aspect of the contractor who needs to get onto that concrete. And then in some applications, there may be some times where they may be able to put more slag into it. It may slow down the 28-day strength, but they may not be needing any strength until later on. So in those aspects, you might be able to change it. So you as a designer and as a contractor could have multiple mixes of that same one that have a different varying amount, and would be able to see through that lifespan of that job how those changes. Because as we all know, and how contractors can and designers can be, is a job might be meant to be starting in July, and next thing you know, guess what? It gets pushed back and it's now starting in February. So those can really impact our global warming impacts and aspects of it. So if we have the flexibility to change those mixes and still make it into that same range, we're going to also help out the performance aspects of the environmental aspects that we're looking to try and do. So with this whole building aspect one, we can then see based on, and this is based on a 50,000 square foot building, custom building, and we're looking at this benchmark building. So by adding in those numbers, we can see what the total would have been. And in this case, we're going to say we're using a mass mix in there with 50% slag. We're going to see the actual amount of CO2 that would have been in there. And if we would have did it without slag in there, we could see that reduction if we would have put one right in here too. So you can get all those totals and all those aspects and look at it from a whole building prospect, which is really what we need to be doing. With that, I'm also going to, and I'll put this up at the end too, is if there's any questions, you can feel free to contact the SCA or SCA members, or feel free to reach out to me and be glad to help you with any questions you may have. So with that, we're going to go into actually starting to use the tool. And actually first, before we start using the tool, we're going to go to how do you get it off of the website. So if we're on the website, what we're going to want to do is we're going to go to the sustainability. You're going to see the different aspects. So if we wanted to just download the EPD, we could download the EPD, or if you want to look at the PCRs, you could look at the PCRs that way. The other way we could also do is we can look at the Lifecycle Assessment Calculator, which is the reason why we're here today. So we would go over to here to click download. We would end up typing in your name. Right, and we'll hit submit. And then we can read through this disclosure, so that way you can make sure that you're using the tool with the way that intended to be. And in case you didn't, then this way, at least you understand, hey, I'm not supposed to use it for this aspect. Then we would hit it as accept. And like we said before, we could download the version 3, or we could download the oldest version. So right now we're just going to download the newest version. And open this file. Okay, let me go to the other one that we had. So now I'm going to go back in and open up this file. So in here, if we were back on the introduction, since we've already been into this one, and I would have had that thing up above that would say enable, I would have enabled, then I would have had a thing that said, do you accept this? And I would hit accept. Now we can look at the difference in the slag substitutions. So when we look at this panel again, I'm going to be using, in this case, I'm using, we're looking at this aspect from a project base. So in this as a project base, we're going to look at saying, okay, we have mass concrete. We also have a deck pours that we're going to be doing on this. So let's say this is a parking structure. So with this parking structure, we can go in here, we can look at the mixes we have. In this case, we want a 5,000 PSI strength. Right now, we're going to say, okay, we had 0% slag. If we scroll over to here, we can say, okay, the mix we're looking to use, if we use it with 50% slag, how does that impact these numbers? We can look at it as a percentage, or we can look at it as the actual numbers themselves and see what those different aspects are. Okay. Then we can go to the custom mixes. We would have typed this information in, right? We can also look at all of these custom mixes that we put. So in this case, since we're doing it as a project base, these 3 mixes for the most part are all identical, other than we just changed the ingredient amounts to adjust for global warming, meaning on the cement aspects. And when we look at cement aspects, when it comes to EPDs, right now, most of the impacts in concrete are going to be influenced by the cement application that going into it. Even though cement might only be 10 to 15% of the total weight or the ingredients that are into concrete, right now, because of the energy intensiveness of making Portland cement, that 75 to 85% of the impacts right now in concrete can be adjusted. So some of it might think of that as a negative, but you can also think of it as a positive, because if we have those impacts right now, we have a lot of different ways and the different aspects on being able to improve it. So if we improve our performance efficiency on the concrete mixes themselves, and also make sure that we're not trying to waste cement by putting in higher strengths than we really need to, then we can actually bring these numbers down fairly easy and fairly significantly quickly. So when we look at this project here, we looked at those 3 ones at the beginning. We can look down here to see what those numbers are. And right now we see if we used ordinary Portland cement, we would have been at 232. We used just PLC, that dropped it down by about 20. And we see that if we use 50% slag in this mass, which that's where slag really works well in, we could see that really we have dropped it almost 100 points on that aspect. If we look at a deck, right, where we might not be able to use as much and you have to increase the strengths up front on a lot of cases, right, we're going to see that those impacts are not going to be as greatly improved, but we're still getting an improvement on those aspects. Then if we looked at it as a whole building aspect, we can then see these numbers over here as a whole on the numbers and all those aspects. So now let's go and say we had this mix in here of the deck. I don't want to really use 50% in this deck mix. We're going back to now saying scrolling it back. We can go and look and see, okay, you know what? On this job, it's going to be in the middle of winter time. So you know what, let's go with 22% because we need it also for ASR reasons or other aspects that you may be looking at. And then you can say, okay, here's what we can get as a number. So if I'm doing that as a number, I'm going to see that in this case, I'm going to be saving about 40% or 40 kgs of CO2 that I could knock out of that building aspect just by doing that. So those are the aspects on that end of it. Okay, I'm going to now open up another one, just a second. Let me move this over. I'll just open up that other folder. So as you can see with this works good for the designers, the contractors, and the producers. So with this tool, we could share this file between all the 3 different groups or the 4 different groups that may be in there. There may be a testing lab who might be making up the mix designs, right? There could also be the concrete producer, the contractor, and then the designers. And they're all going to have their own aspects of how they want or what they want that concrete to be, right? So what we can do is if the intention is to lower our carbon footprint as a whole for not only for the concrete, but all for the building as an aspect as a whole, we can use this tool to help change that. So before where we had the question of if we want to enable, right? So we can get through that disclaimer, we're going to click on that, right? And then in this case, it may ask you this, do you trust this site? In this case, I'm saying yes, because I do. And then on this, I'm going to scroll down, right? In some cases, some people may not have realized that you need to scroll all the way down, hit accept and continue. May just take a second because I'm on here. Okay. And then this is that introduction page that we said before. Here's the slide substitution. So in this case right now, I'm looking at it as I am a ready mix producer, or I am a concrete designer who's looking to take one specific mix and see how I can lower it for what the GSA number may have need me to be. So right now I can put in my mixes. I can look at this, right? And in this case, I'm in the Pacific Northwest, but I'm looking to now do the same concrete work, but now instead of being in the Pacific Northwest, I'm going to go to the Great Lakes. See how notice that changed, right? So we can see that our impacts that are going to be in the Great Lakes may be different than the Great Lakes than they are in other regions. If I went down to the South region, we're going to see difference on those impacts there as well. So depending on where we're at, we need to make sure that we're using the right aspects of what we want. So in this case also, let's say, because remember I told you where those mixes are populated in here now, I could say, okay, we're looking at a 4,000 PSI, or I think we're using a 3,000 on this one. We can look and see, okay, if I use no slag in it, I'm going to be higher than the regular benchmark that maybe that's what the designer had in it, but said must use Portland only cement. And in this case, we could say, hey, we're not going to hit our targets of what we want. So let's say in this case, the GSA is saying we need to have it at 200. Right now, we know we can't get there with what we have. So one of the things we can do is we can bring it down or put a little bit more slag in to see where can I get to that number. So right now, you're going to see, I'm going to blow this up so you can see it a little bit better. But you can see right now I got it to about 198. So with 26% slag, I can reduce that number. Another thing I can do is when I look at those mixes that I had in the back here, I can see, okay, I'm not going to use ordinary Portland cement, but I'm going to use Portland limestone cement. And let's see if I look at an option of using Portland limestone cement, or maybe I'm looking at using 15% ash, or let me look at using 25% slag. How is that going to impact me? Then I can go and look at it and see, okay, here's my information for this 4,000 PSI concrete compared to the benchmark. And let's go back here again, because now we're going to go look and see, okay, we're going to say we're in the southeastern region. right? So we're just double checking that, and we're seeing, okay, here's our impacts. And we know that, okay, GSA says we need to get below 200. So if I'm in the southeast here, I know I'm going to need a mix that's right about here to be able to do that if I'm looking to use the same cementitious amount in those, right, to get that same strength. So now if I want to look at, say, I'm doing it in the Great Lakes, okay, and I go back to that comparison of that benchmark, I'm going to see that in the Great Lakes, it's very easy, a lot easier for me to be able to get to those aspects. And in this case, we really wouldn't use the whole building aspect of it because we're just looking to use it to determine what mixes we want to do. So the other thing is now also what we can do with this is we can go to the designer, right? And say to the designer or the contractor, okay, here's 4 mixes I can provide. Which ones would you like to use, depending on the options and the times of the year that it can be done? And also, the other thing we can look at too is when we look at the concrete mix design information, right? You can see that we can add in different ingredients. So we can have Portland limestone cement, we could have Portland cement, masonry, and slag cements and fly ash. That's kind of giving you your binder aspects. Then we could look at your aggregate part. So you could be coarse crushed aggregate, natural coarse aggregate, right? Crushed coarse fine, which would be like man sand or natural fine sand, right? Or manufactured lightweight aggregate. We can also look at the admixtures that we're using too. And in a lot of cases where if we're using admixtures, we might be able to use the admixtures to help lower our water cement ratio. And by lowering our water cement ratio, we may be able to, in some aspects, lower the total cement content. So we can add in these admixtures and see that they're not really going to impact us on the negative side, but we're going to see by adding them and putting them in here that we could see our global warming numbers going down. The other options that we can look at is we could look at using crushed concrete. We could look at return concrete that may have been used, mineral fillers, silica fume, steel fibers, synthetic fibers, accelerating admixtures. We can have all those in there, shrinkage reducing admixtures, and put all those impacts in there to see how it is and how it's aspecting and how it's affecting things. So with that, that's kind of it on the demonstration. Right now, if you want, Janice, why don't we see what questions we have? And I'll try and answer some questions.
Okay. One of the questions was, is the slide deck going to be available? I put yes. Yeah,
Yep.
it will. And then one of the other questions was how to get unblock macros on the downloaded Excel calculator. You covered that. I don't know if you
Yep.
want to talk about that a little bit more.
Yeah, the main thing, and as you can see when we were doing it, depending on your screen, it may actually need to scroll down and then you would be able to hit that accept, right? So obviously the enable app macros is going to be up on the top. For us to move through this tool, we then hit down on the accept and then you should be good. But if you went and hit the accept first, nothing's going to happen because you need to enable that macro. Those macros need to work. Okay.
Great. If anybody has any more questions, you can put it in the Q&A or the chat, either one, and Shawn will answer it for you.
See, in a lot of aspects, I'll just talk while you're still waiting, is a lot of the aspects with this, where this tool really works well, is when you're looking at it from the design stage right to the production of concrete. Just to require an EPD right off the bat, a lot of cases can be good and bad. The bad part about type 3 EPDs is it's a point in time, or any EPDs, it's a point in time. So it's fixed.
We do have a couple questions. Are admixtures added as ounces per yard?
They are added in as ounces per, yes, ounces per yard.
Okay, is there an
Or, sorry,
avenue?
per 100 weight.
Okay.
Yeah.
Is there an avenue to include a local EPD?
In this aspect, there isn't, because you got to remember, all we're doing is this is basically a dashboard that is reviewing and looking back at the industry information. If you want to look at having a non type 3 specific EPDs, those are aspects are coming out. NRMCA is looking to make one that you'd be able to do that. Another one that is also available right now, especially to the producers that produce globally, that belong to the Global Cement and Concrete Association, or also belong to the Portland Cement Association. They have a EPD tool that can actually create product specific non-verified EPDs, and then actually those ones can actually be then given to a program operator, right, which then can be made into product specific type 3 EPDs. So there are a lot of cement ones that have done that through that route, and on the ready mix ones, those will be coming out fairly soon. There will be some new aspects coming from the Global Cement Association and the as well as the Portland Cement Association's tool to be able to use that for ready mix concrete and have type 3 verified ones, similar to what Athena and Climate Earth are doing currently.
Okay, so we have another question. Is the tool available without charge? Could it be applicable anywhere such as South America?
It could be used there to kind of give you an indication on the numbers lowering down based on the ingredients that you're using. Obviously, the numbers themselves may be different, right? And it really should only be used in North America for this one here. Now you're going to see happening in Europe as well as in other areas that tools like this can start to happen. And it's obviously encouraged to make sure that there are industry ones that can be created in those ones. And then these kind of dashboards could be made there as well.
Okay, we have another one. What life cycle stages of concrete does the calculator consider? A1 to A3 only, A1 to A5, anything environmental impacts included from module C?
In this one here, it's only doing A1 to A3 based on the Ready Mix Industries EPD. If you're looking to do things using that PCA calculator or the GCCA tool, right? The GCCA tool does has aspects in there that brings it into C3, and actually does have carbonation aspects. The GCCA tool links clinker all the way to the end concrete use. So in those aspects, if you do know the lifespan of that concrete that's going to be used, if it gets crushed into a aggregate, is it going to be put into, or sorry, in the concrete side, is it going to be exposed to moisture? Is it going to be exposed to air? All those aspects can be put in, and then it will actually in the tool, when you get the input that comes out, the input will give you those impacts in this section C.
Okay, what is action for materials not included in options like ground rubber?
Ground rubber and all those have not been put in this. All that's been put into this tool, right, as well as the industry ones, are products that have already met or are approved to be used by the building code ACI 318. And one thing we have done is we've used this tool because we have also ready mix as well as cement manufacturing in the Great Lakes region, and we have actually used this tool to give us an indication of our different ready mix plants depending on where they're at. And then we've also used it and referenced it with the Global Cement and Concrete Association's EPD tool, and we were able to see that the impacts and what impacts those, and put the mix designs in and see, do they vary that much or do they not, or how is it changing? So this is also a very good tool to help you look at, before you do make it an EPD, what are the aspects that you want to look at and get down to. So because when you do actually make the LCA EPD, those could have impacts that could change depending on another main factor in concrete is the transportation of materials. So depending on how those materials get transferred and all of that has a big aspect. And especially if you are looking to make an industry EPD, reach out to your suppliers, reach out to how they get the product to your location, because their gates are going to be different. So the impacts can be greatly changed depending on if that, for example, if it's cement, did it come there by boat or was it trucked there? or was it boat, then rail, then truck? All of those impacts can greatly change it. There's a lot bigger impacts and a lot bigger CO2 emissions and acidifications. You'll see those when you're doing it with a truck versus having most of that cement either railed or brought in by barge. Just those efficiencies of the rail and the barge greatly impact those numbers. And that can also impact the numbers, especially on the aggregate end. The aggregate material may not have that much of an impact, but the moving of those materials can have a big impact.
Well, we don't have any more questions for you, Shawn.
Okay, then I guess we get to finish early. And with that, I'd like to thank everyone, and feel free to reach out to the Slag Cement Association if you have any questions. Obviously, you know, you can download this whenever you like. And if you have any other questions, feel free to reach out to any of the Slag Cement Association members, or if you want, you feel free to reach out to me. I'm going to put back on that screen the original slide we had, just so that way people can see it.
Great.
Okay,
Great. Thank you, Shawn.
no problem.
Thank you, everyone who attended. We really appreciate it. Hope you enjoyed this webinar. Thanks so much.